Hi everyone, welcome back to our channel. This is Asim here. So in this 6th episode of Be the Hacker series, we are going to talk about some server-side includes and template injection and how these template injection would lead to remote code execution on big companies like Uber. So these are easy to exploit, but it's difficult to find as always. So yeah, these are not as hard to exploit as the Google bug that we saw in the previous video. So if you haven't watched that, do make sure to watch that video. The link has been shown in the card above. So if you are on this channel, you probably know that the payout of these critical bounties are usually in 5 digits, right? So do make sure that you subscribe the channel, you like the video and share it with your friends so that everyone could get bounties. After watching this video, you could be sure that if you have checked a web app for template injection and you haven't found a web app template injection on that, so no one else would. Why I am saying that? Because in this video we are going to discuss about the methodologies and places to look and how to exploit those bugs, how to exploit template injection in particular to get those critical RCs and all. Watch till the end so that you don't miss out on the key takeaways. So what key takeaways screen is basically meant for is to give you a broader picture of the whole video. So what happens is when you are engrossed in the video, which I suppose you are because I am so good a teacher. So if you are engrossed in the video, the mind pays attention to the minutest details, but it might miss out on the bigger picture. So key takeaway screen is basically meant to tackle that. So now let's move on with the missions. So let's get going. So I have logged into the system. Now let's check basic mission 8. So this password is yet again hidden in an unknown file. Sam's daughter has begun learning PHP and has a small script to demonstrate her knowledge. Requirements are knowledge of SSI, which is server-side include, dynamic HTML executed by the server rather than the browser. So let's check what is server-side include. So on OWASP page we could see how this could be exploited. And let's first talk about what is server-side include. So basically it's dynamic content that's being included in the HTML that's being served to the user. So like suppose when you open a web page and you see your name, so that's like dynamic content for every user whosoever visits that page. So they would see their username when they have logged in, right? So that's the dynamic content we are talking about. So usually it's being done by templating engine. So there's a fixed static template for HTML files and the values are being replaced with whatever value the server is being like passing it to. So some of the popular templating engines are Mustache, _, Handlebar.js, Embedded.js and Jade templating. One of the popular templating engine for Python is Jinja and Jinja 2. So it's being exploited quite like we would see some of the reports where Jinja is being exploited to execute code on the server. So eventually getting remote code execution. So again let's talk about how you would get the payloads for this. So again you could go to the same repo PayloadAllThings and then there is a server-side template injection. So we would talk about this later. So we will talk about the methodology of how to find that out and how you could like check for that. In the report part we would see that. Let's come back to the OWASP page. So SSIs are directives present on an application used to feed an HTML page with dynamic content, as I was talking about. So how to check is, it is possible to check if the application is properly validating input fields by inserting characters that are used in SSI directives. So these are some of the characters that are used in SSI directives. There could be others, but these are some of these. So another way to discover if the application is vulnerable is to verify the presence of pages with extension .stm, .shtml and .shtm. However, it's not sure that if these pages are there, then that would be vulnerable, because as you could see that it's only vulnerable if the web server permits the execution without proper validation. And vice versa, these pages are not available there, then the web server is protected. There could be server-side include by other methods also. So what the attacker could get from that is they could get access to sensitive content, password files, as we would see in the Sam's case, and also they could execute shell commands. We would see in some of the reports how shell commands were being executed or similar in this very mission also. So these are injected in input fields. So whatever input you get, try including these and the other template payloads that I am gonna show. So you should try these in the input fields, like if there's a search bar, or if there's a username field, there's a like profile name field, or there's an email field, any field that you feel there's could be input and these characters are permitted. So try that. So what happens is the web server passes and executes the directive before supplying the page. So your payload would eventually get executed, and that would you would get the output of that in the page that being received by you. So first example, let's explore that. So here by executing this command or this server side include, the ls command would be executed on the server, and we saw that ls command is used to list the files in the current directory. So that's pretty much about how the exploitation works and what it is actually and how to discover that. Let's move on to the mission. So here he talks that Sam remains confident that an obscured password file is still the best idea. I think Sam should have taken some lessons from the previous mission. He agrees that he was screwed up the calendar program. That's totally true. That's how we got access to the previous mission's password. Sam has saved the unencrypted password file in this directory. However, Sam's young daughter Stephanie has just learned to program in PHP. She is talented for her age, but she knows nothing about security. She recently learned about saving files, and she wrote a script to demonstrate her ability. So suppose if I write hacking simplified, so that should get saved by somewhere. So let's check. So it says, hi, hacking simplified, your name contains 18 characters, and it's being saved in a temp folder and with some random character file name, and then there's a shtml. So it affirms our suggestion that shtml files, there could be like SSI injection. So we should try this command, I suppose. So if we execute this, let's see. So it should have, so yeah, you see we could have all the shtml files on the directory in the current temp folder. So what happened here is that this command ls command was executed on the server, and then that output was written in the file that Stephanie made. So basically we could execute any command, and then we could see the output of the command in that folder. So let's try this command to get the content of the parent directory. So we see that this is one of the file, and then there is this index.php and level8.php, and then there is the temp folder. So let's check this for the password. So it should contain the password. It would have been obvious by now. So another method could have been if we would have done this cat and then the file name, whatever was the file name, this. So I'm just trying to check if cat command is allowed or not. So if this could also produce the same output, I guess. So this is that one. So yeah, so if you could see, it's the same. So that's because cat was also allowed. So let's finish this mission and go to the more interesting part, basically the reports. So the first report is from Orange Sai. He's quite a famous researcher, and he reported this to Uber on, I guess it was March 25th, and it was 4 days after Uber started their bug bounty program. It was code injection, and which fetched him $10,000. It was RC in Flask. Some of the popular frameworks of Python, they use Jinja 2 template. That's the reason I was talking about Jinja 2 template earlier. So what he could do is he found that there was an RC in rider.com, and if you change the profile name, so profile name is one of the input parameters as we talked about earlier. So you could insert a template here like 7 into 7. So this 7 is the character, and into 7 you would receive an email. Your Uber account information has been updated, sent by support, and the mail body you can see your name is as 77, like 7 is printed 7 times. So it's a classic case of template injection. So he says that there could be a remote code execution as well, since there was a length limit. So it tried these to get all the classes and then other commands to do some other similar kind of stuff. So let's check the images for this. So in this image he shows that a lot of like internal types and all those things were printed. Let's check some other outputs. So here's the actual screenshot of the mail that he got, where you could see that 7 7s were being printed. So he tried other things also, and those were getting printed on the email. So that's pretty much all that was required to exploit this. So let me show you the payload thing of similar, like let me show the payload of this. So if we go for Jinja, so Jinja, so you could see that the basic injection is 7 into 7, that would result in this. And since it was a Flask application which was confirmed by this, so he further tried to dump all the classes and some other payloads. So these are some of the payloads that he tried. He could also use this to dump all the config variables, and then he could also read a remote file, like etc password file and flag files. He could also write that. So these are some of the things that you could do. So pretty much everything that's pretty much everything that you could do with this. Let's come to the second report. So it's excesses due to template injection. It's reported by James Kettle, and he's also a famous researcher. So it was reported 3 days before, like before Orange reported it, if you would see. So he reported on March 25th, that was the 4th day, and March 22nd was the first day of Uber bug bounty, I guess, or the second day. So he found that on developer.uber.com there was this query parameter Q and WRTGs. So if I copy this and decode the URI, so you would see that there are 2 curly braces for that. So that's being URI encoding in that, URI encoded in that, decode URI component. So query WRT, so 7 into 7 was being executed as 49. So basically there was like template was being processed on the server backend and being displayed. However, instead of doing remote code execution or similar like class injection or finding classes like Orange did, what he went on to do was he tried to execute a JavaScript, like execute alert on that, and that's what fetched him $3,000. But I suppose that even this same thing would have been possible if like James Kettle would have tried that. There's a blog that he wrote, so Portsugar blogs are good. I have read that, and those are quite informative. You should go and read those. So what he could do was he did the same thing, and then he created a payload. So this was quite a complex in comparison to the Orange payload, because he tried to bypass, like to escape the Angular sandbox. So Angular is a framework to create front-end applications. So that's pretty much about this bug. So there's a white paper by James Kettle through Portsugar Web Security. So here he talks about server-side template injection and RC for the modern web app. He talks about how to detect it and how to do expert development for different kinds of templating engines such as Jade, Twig, Smarty, Velocity, FreeMaker, and all this stuff. So it's quite informative. I would suggest that you go and read this. It would be a good read. So let's come to the third one. So this bug is quite interesting because the bug was not as evident as it was in the previous 2 cases. So what happened was, so this researcher, he tried a username 7 into 7 in the web application in the username field, but the application took the payload and it printed it out as a string everywhere, and it didn't execute the payload as is. So the first thing that you should take notice of, that you should check every pages wherever the username or wherever the input that you have fed is being like processed, because it could be that on the main page the profile is being treated as string, the username, but on other pages there could be that the username is being executed like a template engine, because not every page is being treated equally, right? There could be different application in the backend serving a different page and similar stuff. So it's better that you check all the pages where your input could be reflected. So then he tried the forgot password thing, and once there was things like email ID and username. So mail was sent to the user with a reset password link, as it is usually the case. So he tried his email ID or username, so mail was sent, and even in the mail the payload was not executed. So further he tried that he entered the email ID in both username as well as in the email ID field. So when this email was sent, so the payload was executed, and instead of 7 into 7 he got a 49. So that's 7 into 7, it's 49, right? So he got that. So he tried another payload just to be sure which templating engine was on that. So he got that 7 times 7 was printed. So he was confirmed that there was a backend, Ginger 2 backend. For this, he was awarded $1,200. So some of the takeaways was that you should check for every parameter wherever you could do an input, and then try to fuzz with the same input or similar stuff. And the third thing is very important, that's never give up, because he mentioned that this program was 5 years old and still there was a critical bug. And it's not about program being old, it's about, since the programs are shipping code every day, and maybe in a day, or maybe in a day or two, maybe in a week. So they have a huge code base and a lot of things is being shipped out. So you should always check for that. There could be functionality being added or removed, or code being optimized, and then there could be a security bug introduced due to that. So you should always check that. So before closing this session, let's talk about the methodology of finding the template engine. So coming to the PayloadAllThings. So here's the methodology. So first you should try the $7 and if the green line shows the execution. So if there's an execution, then you should try A and comment and B. So if it's being shown as A and B and comment is being like neglected out, so that's a Smarty engine, then you could try the Smarty payload. If it's not the case, then you should try this payload. And if there's a green, like if ZAB is being shown, since A and B is being joined to Z, so that's the Mako templating engine. If that's also not the case, then there could be a unknown templating engine for which the payload might not be here. Or you could try every payload because they are not sure about which template using this methodology. Moving on the second path, so if the first payload failed, then you should try for 7x7 using 2 curly braces. And if there's no output there, then it's not vulnerable. However, if there's an output, then you should again try with 1 7 as the integer and the other 7 as the character. So if it's being reflected as 7 times 7, then there's a Ginger 2. It could be Ginger 2 or it could be Twig. And if it's not being reflected as that, so there could be some unknown templating engine, and then again you could do as the above, that you could try different templating engines and stuff. So that's pretty much about for today. Have a nice day. Hope that was worth your time.